my friends. This video is presenting 8 old exams questions related to functions and domains from lecture 27. Let's start question number 1. Given the piecewise function, you have here a function that has 3 pieces and there are conditions. X less than 1, use this part of the function. X between 1 and 5, closed at 5, open and 1, use this one. X greater than 5, use this one. So we need to find f of 1 plus f of 6 divided by f of 5 times f of 0. The only thing we have to do here, take the number x. C, you have to check in which interval this number lies, then you can use the part of that function. Now, let's go inside here. F of 1, where is 1? 1 in the first one here. X less than or equal to 1, so 1 is there. So I put 1 squared plus 3 times 1 minus 2. See, when you simplify all this, what do you get here? 1 plus 3, 4 minus that, 2. So we find f of 2 again. So where is 2? 2 will be here between 1 and 5. So I put this absolute value. So you have to go slowly here. F of 0, where is 0? 0, x less than 1. So 0 is there. 0 squared plus 3 times 0 minus 2. And then f of 5, etc. 5 closed is there in the absolute value. And then we have f of 6. See, f of 6 is greater than 5, so I take only constant minus 28. Simplify all this, you will get 23 over 10. Please check the numbers. Question number 2, we have a function and we need to find the expression f of a plus h minus f of a divided all by h. H is not equal to 0 and we need to simplify the answer. So it's only replacing a plus h, that's all x. In every x, see here we have x squared and we have 2x. So I put a plus h in this x and in this x. Simplify all this, minus f of a again, I put a squared and here 2a. And then I simplify all this divided by h. I think you know how to do that. It's a little long. A plus h, we have the formula here. A squared plus 2ah plus h squared minus 2a minus 2h, multiply here. See, f of a, I left it. F of a, then you need a bracket here. A squared minus 2a plus 5. This is all in the bracket here, f of a. So the image of the a. Simplify everything, you will reach to this point. Take h is a common factor and then cancel the h. So 2a plus h minus 2 is the answer. Question number 3, we have seen similar in the algebra course 27. Find the net change between the input values 4 to 10, and we have this function. So 4 is the a, 10 is the b as you know, and the net change will be f of b minus f of a. So a is 4. See, I started with b, no problem. You can start with b, you can start with a, it's up to you. So I started with b, f of b, f of 10. So I put here 10 plus 2, 10 minus 3. So that will be 12 over 7, leave it. F of a, just take a 4. 4 plus 2 over 4 minus 3, that's 6. So the net change we need, f of b minus f of a. 12 over 7 minus 6. So that will be minus 30 over 7. Find the domain of these functions. I put here 3 of them. See, on purpose here, I put the same expression, 1 over something, 4th root of something the same, and something without any fraction or radicals. I think you have tried this. 1 over this, that's easy. Just factor it and look at the zeros. See, when you have a rational here. I put also a summary of the domain methods, how to find it, in the lecture 27. So the first one, I factor here. See, this cannot be 0 in the denominator. So x squared plus 5x minus 24 cannot be 0 because we have 1 over that. So if you factor it, x plus 8, x minus 3, correct? So minus 24 plus 5, yes. So what will make the denominator 0? 3 minus 8. Now look at the domain, R, which means all real numbers except minus 8 and 3. Now the same function, but we put here square root without fraction. See, now that's different. I have to take all the radicand here, everything, capital M we call it. In lecture 27, we called it capital M. X squared plus 5x minus 24 greater than or equal to 0. Then you have to make table of signs. See algebra course lecture 27, how to do the big table. And then you get minus infinity to minus 8 union closed 3 to infinity. Now this function, the same function without radicals, without fractions, that's a polynomial. No condition on the x here. So domain will be R. We can write R, or we can write minus infinity to plus infinity, or we can say in English, all real numbers. Now another set of domains, old exam question number 5, 3 parts, A, B, and C. 1 over 2 minus absolute value x minus 5, square root of this one without radicals, without fractions, similar to number 4, but the idea a little bit, it has an absolute value here instead of a polynomial. Now, the first one, I should not take a denominator 0. I cannot accept denominator 0. So I take 2 minus absolute value x minus 5 cannot be 0. What will make it 0? So this is case number 1 in algebra course lecture 26. Solve this absolute value equation. X will be 7 or minus or 3. So the domain will be all real numbers except 7 and 3. You have to see case 1. See, in lecture 26, there are 3 cases. Case 1, we have seen also down case 2, also case 3. You can see it in other questions. So case 1, the absolute value equation, take 2 on the other side, and then becomes positive with the absolute value. So it will be x plus 5 is equal to plus or minus 2. All right. So all real numbers except 7 and 3. This one here, when we have the same expression under the radical, see, we should take all this radicand, 2 minus absolute value x minus 5 greater than or equal to 0. We did many times there. No need for this table of signs because this is absolute value. Use case 2. So it will be closed. The domain will be closed 3 to 7. Please check the lecture 26. There are many questions there. And here we have no conditions on the x, no fractions, no radicals. Domain will be R. That's a V shape in the graph. Now, this is number 6. A tough question maybe. Find the domain of this function, 4th root of 45 minus x over this plus 1. Now we have to take the radicand here, all this big radicand plus 1, all of it greater than or equal to 0. Why? Because we have here the index even. So the index is even. I have to take the radicand. You can simplify it. See what I did here? I simplified under the radical and then take the radicand greater than or equal to 0. Or you can take all this, it's the same. You take 45 minus x over this plus 1 greater than or equal to 0, then you can simplify it. It's the same idea. So let's see here what we get. 45 minus x plus x squared plus x minus 20. X squared, x will be cancelled. 45 minus 20 plus 25. Oh boy. So now the radicand is x squared plus 25 over this. I should take all this greater than or equal to 0. I factor in the denominator x minus 4x plus 5. Unfortunately, I cannot factor the one in the numerator because it's positive here, x squared plus 25. I cannot factor it in the real numbers. but in the complex numbers I can. So now the zeros are only two zeros, 4 and minus 5. And remember, there is a little trick here. X squared plus 25. You have to put it on the table. See, table of signs here, algebra course lecture 27. Put it all plus, plus, plus. Every number you put there, any number, it will be squared plus 25, which means plus, plus, plus. Now this one you have to test, take a point here, let's say minus 20. This becomes minus minus, take 0. This becomes minus a plus, and take here 15, you get plus and plus. See, even we have equal here, greater than or equal, but we have to make open. Why open? Because these numbers that will make the denominator 0, we cannot accept them. So x minus 5, 4 and minus 5 there, we cannot accept in the denominator. So we make it open all. That's the domain of this big function. Another idea, in the domain, we have a square root. And we have all this. Can you try it, please? Take a minute. Find the domain. I think you know the idea now. Look at the index. The index is even. It's okay. Take the radicand. So what is the radicand here? All this. Start here. X squared plus 3x all divided by 16 minus x squared. All this greater than or equal to 0. Then you factor up and down here because we can factor up and down. Then it looks like we have a big, big table. We have a 0, see x or x minus 0. We have minus 3, we have 4 and minus 4. So this is a big table. Now, you put all the factors here. You see this x here, x and x plus 3, 4 minus x, 4 plus x. Take a number. Let's take a number here. From minus infinity to minus 4. Let's take maybe minus 10. See, if you put it in the x, that's a minus. That's a minus. That's a plus here. 4 minus minus 10, that's a plus. 4 minus, that's a minus. See, when you divide and multiply these signs, because divide and multiply is the same, when you divide and multiply 3 minuses and a plus, the result will be minus. And then continue the same way. One important remark here, do not memorize any table, please. Because every question has different factors, different zeros, different table of signs. Now, when you finish, you need to check the positive. Where's the positive? Greater minus 4 to minus 3. See the union, the positive 0 to 4. Now, we have to put all closed because we have greater than or equal. But remember, in the denominator, we cannot accept 0. So at minus 4, we make it open. At 4, we make it open. At 0, we make it closed. It's okay. At minus 3, we make it closed. Be careful here about checking. Now, question number 8, we need to find the range. There are 5 questions here, A, B, C, D, E. As I mentioned in lecture 27, to find the range, you have to go slowly. You have to think. You have to imagine, if you can imagine the graph. There is no rule, just a formula like quadratic formula. So let's see. The first two, x squared plus 1. If you try to graph it, we know f of x is y, and x squared is a parabola. Plus 1, see, the graph will start from 1. Whatever value for the x here you put, whatever value. If you put minus 5, minus 6, minus half, 0, 7, 1, 2, 50, it will be something plus 1. So it will start from 1. The minimum is the 1. So the range are the y values. Remember, the range are the y values. So it will be closed from 1 to infinity. By time, you will see more and more questions. It will be easy, especially in lecture number 29 that will come soon. Now, this one here, f of x minus square root. Remember always, f of x is y, so y equals minus. See, it's all negative, minus, because we have minus. The square root itself is positive, so minus times plus is minus. So all the y's are minus in this one. Now, if you put minus 2 there, especially minus 2, it will give you square root of 0, which is 0. 0 or minus 0 is a real number. So 0 will be in the range in the y if x is minus 2. So the maximum number here is 0 in the y, and all are negative. Now, number C, we have seen f of x is equal to 1. That's a horizontal line. See, this line has many points, right? Many points there. Many infinity of points. Different x values, but only one y equals 1. So the range here, only 1. 1 point, 1 number, f of x is equal 1, y equals 1. This one a little harder. Later you can see easily when I give you how to graph this one. Minus absolute value x minus 3 outside. Now, you can take some points to graph it, or you can make some analysis. This is a V shape. We know the absolute value is a V shape. The absolute value is a positive number, and there is a minus here, so it's all negative. If we don't have here the minus 3, the graph will be stopping at the x-axis here. But since we have a minus 3, it will go down. The graph will go down, shifted minus 3. So in the range, we take all the negative values until minus 3. We don't have any value higher than minus 3. So the range will be from minus infinity to minus 3 closed. If you need the domain for this, or real numbers. This one, minus x minus 5, that's a straight line. You see no absolute value, no square, no parabola, no fractions. Straight line, oblique, not horizontal, not vertical. The domain and the range are minus infinity to plus infinity, both domain and the range of a straight line, not horizontal, not vertical. Now, these are the solutions I put here. For more examples, please, if you want to see more examples, you can see the video Algebra course lecture 27 about functions. Thank you for watching. If you like the video, you can subscribe and share it, please, with your friends. I wish I can see you in another video with another topic. Thank you very much for listening.